go ahead and get started. So our essential question, and I know we're going to go ahead and write EQ, is how can I find equivalent fractions using visual models? Now, for our purposes today, we are going to use number lines and tape diagrams, and I'll show you both of those, but I want you to have this written in your journal. So Izzy's mom is baking a cake, okay? So the first thing I want you to do is go ahead and draw out that cake, and we're just going to draw a rectangle to show or model this cake. Essentially a tape diagram, but just a little bit more rectangular shaped. And if Izzy's mom is baking a cake, she put chocolate frosting on one half of the cake, and she put vanilla frosting on the other half of the cake. So if I think about that visually, I know half of the cake would be represented in that way. So I would partition that one time to get the two equal pieces. Now we know this side is chocolate, and this side has vanilla frosting. We can see here that this represents one half of the cake, and this side also represents one half. So we're gonna go ahead and put that on the top. Then Izzy's mom cuts the cake into fourths, all right? So what fraction, and I'll pause there for just a second, if she's gonna cut it into fourths, okay? So if we have these two pieces and she's gonna cut it into fourths, we need 4 pieces, so we're gonna need to partition. Now I could do this a couple different ways. Now I could partition and create more columns, or I could partition across and create another row. So I'm gonna kind of go here to make it just more visually pleasing, but I want you to know that you can do this either way. So this is gonna create my fourths. So I can clearly see that on this side, chocolate is also, now I have a new unit fraction, okay, which we've learned about. This is 1/4, this is 1/4, this is 1/4, and this is 1/4, giving us 4/4 or our 1 whole. Now, if I look at the chocolate, it was originally 1/2, but when I partition my cake into 4 equal pieces or fourths, now I can see that 1/4 plus 1/4 is equal to 2/4. So therefore, I can see that 1/2 is equal to 2/4. Okay, so if I know that, I can go ahead and write my equation out over here. 1/2, which we saw, half, is equal to 2/4. Now it was the same thing over here. 1/4 plus 1/4 gave us that 2/4, which was the same as that 1/2. Okay, so if I go on and ask a couple questions, what fraction of the cake has chocolate frosting? 1/2 of it, which was our original model. We had 1/2. Now, how many equal parts should the cake be divided into to show fourths? Well, when we went from halves to fourths, we partitioned it twice to get 4. I'm throwing markers just like I do in class. 4 equal pieces, okay? So we partition it twice there, okay, to get 4 equal pieces, or once to get those fourths. All right, now we've already divided our cake and we drew our line to create 2 rows. 1 row, 2 row. We could have drawn it another way. Now we've shown that 1/2 is equal to 2/4. Now mathematically, we can also think about this. To get to from 2 pieces to 4 pieces, I multiply by 2. Okay, by partitioning once, I multiply by 2. So if I think about this, 1/2 times 2 halves, or 1 whole, is 2/4. So it makes sense mathematically. Did the amount of cake with chocolate frosting change? So did the amount of cake with chocolate frosting change? No. 1/2 is equal to 2/4. We still have 2/4 of that cake that's chocolate. Only the number of pieces, because mom wanted 4 rather than 2. Awesome job. So now, here's where we're gonna draw a couple more models. So once you're finished, you can pause if you need to. You can use models, okay, such as pies or tape diagrams to model equivalent fractions. So let's look at an example right here. So let's go ahead and draw a circle. And I want you guys to partition it into fourths, okay, which means I need 4 pieces, and I'm gonna go ahead and shade 1/4 right there. Okay, now I want to represent the same amount, but with a different fraction. So this was 1/4. And if I draw the same model here, and I'm going to start with my fourths, and I know that this was 1/4, but I can do something to show that 1/4 is equivalent to another fraction. So let's partition this right here down the middle, and then right here down the middle on this other side. So we're just kind of cutting, and now we're going to have 1, 2, 3, 4, 5, 6, 7, 8 pieces. So we can see each one of those, the unit fraction for each one of those pieces is 1/8. And I can clearly see that there's 1/8 here and 1/8 here. So 1/8 plus 1/8 is 2/8. Now I can clearly see that 1/4 is equal to 2/8. Now let's also look at this mathematically. So I knew to go from 4 pieces to 8 pieces, I partitioned each one of those fourths twice. So I'm going to say that one more time. To get from 4 pieces to 8 pieces, I partitioned each fourth, so this piece right here that's shaded, into 2 equal pieces. So I'm going to multiply by 2, and that gave me my 8. But when I'm finding equivalent fractions, I have to multiply the denominator and the numerator by the same thing. So I'm going to take my numerator and also multiply by 2. 1 times 2 is 2. 4 times 2 is 8. Therefore, we can see that 1/4 and 2/8 are, in fact, equivalent. All right, for our next problem, we're going to look at a tape diagram. And so I want you guys to go ahead and draw this out. And we're going to do a long rectangle here, okay? And what I want you to do first is partition it into fourths, okay? So we're going to need 3 lines. 1, 2, 3. And they do not need to be perfect. Okay, and we're going to show 1/4. So I'm going to go ahead and shade 1/4, and I'm going to go ahead and represent, that's my 1/4. Okay, so do that now. Pause if you need to. So there's my 1/4. Now I want to show that this is equal to 2/8. So if I partition this fourth into 2 pieces, okay, so just like that, I'm going to draw a dotted line. It's not perfect, but I have to do that with each one of these pieces. So I did it here, I'm going to do it here, I'm going to do it here, and I'm going to do it here. Okay, so now I have it. So as the unit fraction was 1/4 before, now I know that I'm going to have a new unit fraction. So this piece is worth 1 out of 1, 2, 3, 4, 5, 6, 7, 8. Therefore, 1/8 plus 1/8 is 2/8. So I can clearly see that 1/4, which is what I had originally, is equal to 2/8, just like that. Okay, so pause the video if you need to and make sure that you see that visually. Now we're going to move to a number line. So we had just our pie chart circles and we have our tape diagrams here. Now we're going to show this using a number line. We're going to go ahead and draw it all the way out from here to here to give us a lot of space. So use up that whole, I kind of have mine written across my paper just like this. So I'll show that one more time. So however you want to show it or model it. But so we're going to find 1/4. So obviously, or we're going to prove, I'll go ahead and write this up top. 1/4 is equal to 2/8. Again, so same fraction that we're proving. 1/4 is equal to 2/8. So first, I'm going to start off with 1/4 and model 1/4 on this number line. So if I know I need 4 pieces, which that's my denominator, we're going to start at 0, 1/4, count it out. 2/4, 3/4, and 4/4 or 1 whole. I'm going to extend that out and go ahead and draw. So we know really this is 0/4 and this is 4/4. Okay, making sure we're very clear on that. Now, I want to go from 4 pieces to 8 pieces. Now, we all know mathematically to go from 4 pieces to 8 pieces, what would I have to multiply 4 by? What's our fact we know? 4 times 2 equals 8. So I'm going to take each one of these fourths and partition it once to get 2 pieces. And I'm going to say that one more time. We're going to take our fourth, and we need 2 pieces from that fourth. So we're going to partition it once, just like that. So I've got 2 pieces. So 2, 4 pieces, 6 pieces, 8 pieces. So whatever I did for this side, I do, or excuse me, this this portion of our number line, I do that with all of them. So I'm just going to do it once. So now I can see I have a new unit fraction, 1, 2, 3, 4, 5, 6, 7, 8 pieces. So my new unit fraction is 1 out of 8 because there are 8 pieces. So this is 1/8, 2/8. And actually, I'm going to draw this up top to make it a little more clear. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, or 1, which we know is 8/8. And this was also 0/8, if you just want to pay attention to that. And now we were trying to prove that 1/4 was equal to 2/8. Therefore, I'm going to go ahead and plot right here. There's 1/4, and it is indeed equal to 2/8. Now, there were a couple steps that required us to get there. But as you can see, we did it using, we showed 1/4 was equal to 2/8 using circles. We used a tape diagram, and we also used a number line. So 3 different strategies. And remember, pause, go back, watch them again. You guys are awesome staying with me. 2/3 is equal to 4/6. So I want you guys to go and write this. 2/3 is equal to 4/6. This is what we're going to prove, okay? And we're actually going to use a tape diagram. So I want you guys to go ahead and think 2/3, okay? And I'm going to use a tape diagram. How would I show 2/3? So pause the video, and I want you to see if you can prove how 2/3 is equal to 4/6. Welcome back. I hope you paused the video and tried this to see if you could do it. But we have 2/3 is equal to 4/6, and we want to prove that. So 2/3, I want to draw 2 lines to get 3 pieces. And I'm going to shade 2 of those 3 pieces. Okay? And I want to prove that it's equal to 4/6. Now, how do I get from 3 to 6? 3 times what gives me 6? 2. Okay? So I'm going to partition each one of these thirds into 2 pieces to get 6 pieces. So here we go. Here's my third. I'm going to cut it into 2 pieces, which means I only draw 1 line. But whatever I do with this piece of our whole, I have to do with the rest of them. So I'm going to do it again and then do it again. So now I have a new unit fraction, 1 out of 1, 2, 3, 4, 5, 6, which is what I was going for. 1/6 plus 1/6 is 2/6. This piece is also worth 1/6 plus 1/6, which is 2/6. So 2/3 is equal to 2/6 plus 2/6, which is equal to 4/6. Therefore, 2/3 is equal to 1, 2, 3, 4/6. Okay, and we can also prove this mathematically. 3 times 2 is 6. 2 times 2 is 4. Okay? All right, so one more problem that I want you guys to try out. Remember, pause that if you need to. Okay? All right, let's look at one more. We're going to use a number line. So we're going to prove that 1/3 is equal to 2/6. So go ahead and write that out. And I want you guys to draw your number line and just extend it out. First, we're going to show 1/3. Okay, so we're going to start our number line at 0. We also know that's 0/3. Okay, so we're starting here with our smaller fraction. So 1/3, we're going to count up 1/3, 2/3, 3/3, which we know is 1 whole. So we can cut off some of my number line there. All right, and we want to go from 3 pieces to 6 pieces. Well, how do I get from 3 to 6? 3 times 2 equals 6. Okay, so I'm going to take each one of these thirds, get it into 2 pieces. So I just draw 1 line, 1, 2. But whatever I do here, I've got to do 1, 2, 1, 2. So now I've got 1, 2, 3, 4, 5, 6 pieces. And I can relabel that 1/6, 2/6, 3/6, 4/6, 5/6, or 6/6, or 1, if you're thinking about it that way. Okay, so I can clearly see that 1/3 is equal to 2/6, just like that. And I can also see mathematically, whatever I do to the denominator, I have to do the numerator. 1 times 2 is 2, 3 times 2 is 6. So that's just a quick check for you. And this was using a number line. All right, beautiful job listening today. I hope that wasn't too long. You guys did awesome. Now, I'm also going to post a problem that you can do on your own that goes with this so that you can practice the skill. And again, pause and go back as needed. Make sure you've drawn these models. You guys did awesome, and thank you for listening. Bye.